Hi everyone and welcome back, and in today's lesson we are going to learn about a geometric series that converges. So in fact we're going to learn about a convergent geometric series. Now before we do that, I would like to bring 3 points to your attention. Now the first one is one that you already know, and that is when we have a geometric series and we want to add a certain amount of terms. For example, we want to add the first 10 terms of a geometric series. Then we make use of the following formula, and we learned this in a previous lesson. Okay, let's move on to point 2. In point 2, we want to know what do we do if we have a geometric series and we add an infinite amount of terms, but the constant ratio is greater than 1. So let's look at what do I mean. Now here we have a geometric series and we want to add all of these terms up to infinity. So let's just have a look at the constant ratio. So 6 divided by 3 is 2 and 12 divided by 6 is 2. So can you see that this constant ratio is greater than 1? Now that's a very important fact, because if the constant ratio is greater than 1 and we want to add an infinite amount of terms, our answer will be infinite. So we cannot really work this out. You just know that the answer is infinite. Now that brings us to the third point, and this is the one that we are going to learn today. When we add an infinite amount of terms, but the constant ratio is a fraction between -1 and 1. So it's very important for you to remember this. We want to add an infinite amount of terms, so we want to get the sum to infinity, but the constant ratio is a fraction between -1 and 1. This is what we call a convergent geometric series, and we make use of the following formula. So the sum to infinity is equal to a, it's the term where we start to add up, and 1 minus the constant ratio, where this constant ratio is a fraction between -1 and 1. Now let's go deeper into this. Now let us have a look at what does the word converge mean. Now to do that, we are looking at the following geometric series, and it has a constant ratio of 2 divided by 4, it's a half, 1 divided by 2 is a half, 0,5 divided by 1 is a half, 0,25 divided by 0,5 is a half. So can you see that this constant ratio is a value that is greater than -1 but smaller than 1. Now this is a very important thing to remember, that the constant ratio has to be greater than -1 and less than 1 for this geometric series to be convergent. So here we go. Now we want to add all of these terms up to infinity. Now it's quite easy to add the first 3. So 4 plus 2 is 6 plus 1 is 7. And I'm going to stop there, and I'm going to let you remember that the first 3 is 7. And then we will have a look at all these terms that are fractions. Because when we have a fraction and we multiply it with a fraction, we get a smaller fraction. So if we add up all these fraction terms to infinity, you will see that you will never really get a 1. You will not get a complete 1. You will end up with something like 0,9999999. So you will not end up with a complete 1. So we are moving towards 1. Okay? So what we do now is we just simply say 4 plus 2 is 6. 6 plus 1 is 7. And then all of these fraction terms are moving towards 1. So 7 plus 1, it's 8. So this entire series, if we add it to infinity, moves towards 8. It will not really be an 8, but it will move towards 8. And that is what is meant by a convergent series. We're adding to infinity and we want to know what is that value that it is moving towards. Now, if we want to do this way quicker, we can remember that the sum to infinity, okay, and we can only use this formula when we know it's a convergent series. So the constant ratio has to be a value greater than -1 but smaller than 1. So then we use the following formula. which is a, which is the term where we start to add up, which is a 4, there it is. 1 minus the constant ratio, which is now a half, and there it is. Then we put this into our calculator and we end up with an answer of 8. So the sum to infinity is equal to 8. Now, this is very important for you to remember. We can only use this formula if the constant ratio is a value greater than -1 but smaller than 1, okay? And we want to add up these terms to infinity. Then we can say that this geometric series is a convergent geometric series, and we make use of this formula. And I hope to see you again next time. Bye.